Welcome to the true 1.6 page 4. I just noticed that I labeled the page 3 as page 4, but should be labeled correctly on the thumbnail for our video. So anyway, 1.6 page 4. Determine algebraically whether the function is one-to-one. So to do that, just start finding the inverse function. And if you find the inverse function with no little sneakiness to it, and you'll see what I'm saying about that when we get to a problem, then it does not have an inverse. Verify your answer graphically. If the function is one-to-one, find its inverse. I'm actually going to find its inverse first. So we change y into x, x into y. Solve for y. 3y equals, subtract 5 on both sides, x minus 5. Divide 3, y equals x minus 5 on 3. Nothing strange happened. And by that, you'll see exactly what I'm talking about in number 64. Therefore, determine algebraically whether the function is one-to-one and verify your answer. The function is one-to-one. Because it just turned into a line the other way. It's just a plain old line, nothing special about it. It has a slope of 1/3. So it is one-to-one. Therefore, it has an inverse. And the inverse is f inverse of x is x minus 5 on 3. Or if you like, 1/3 x minus 5/3. Not going to have you graph that. You're welcome to if you want. So this one, fine. Let's just go ahead and start to try to find the inverse. So I would go y's into x's. I'm going to multiply both sides by y squared. Y squared x equals 4. I'm going to divide both sides by x. So far, so good. Y squared equals 4 on x. And how do I get rid of a squared? And hopefully there's the big chorus of plus or minus square root or plus or minus the square root. So I get y equals plus or minus square root of 4 on x. And if you have to introduce a plus and minus, how in the world can this function be one-to-one? Because if I put 10 in for x here, I get two different values for y. Therefore, it is not one-to-one, no inverse. Okay? 68. X equals y minus square root of y minus 2. So solve for y. X squared equals y minus 2. Y equals x squared plus 2. Is that a problem? Not a problem at all. Our graph of this, if we were to graph this, would look like that. Now, that is the top half of this parabola. So our inverse function, f inverse of x, is x squared plus 2. However, we're only looking at the top. For the inverse function of it, the inverse function would look like this. This is the sneaky part that I said we're going to talk about later, and we're definitely going to get into it in number 78. If I looked at the inverse function of this, this would reflect over to here, this would reflect up into here somewhere, and we'd have that. That's half of, there's our x squared plus 2 parabola right there. But we're not dealing with all of it, we're only dealing with the part of that that's over here to the right of 0. So we actually need to state here x is greater than or equal to 0. So that part, a little bit sneaky right there. But it does have an inverse function. But it's only half of that upward parabola because this was here. Had this been negative x minus 2, we'd be dealing with the bottom half of that, the left half of this, where x is less than or equal to 0. Okay, so definitely understand some challenges there. Okay, more discussion along that same thing. Here we are back to greater than or equal to 0. So let's see, we've got x equals y squared on y squared plus 1, and I get y squared plus 1 times x equals y squared. And I have to solve this thing for y squared. So y squareds are my troublemakers. I need to get my y squareds as isolated as possible on one side. So I'm going to distribute this. Y squared x plus x equals y squared. I think I'm going to bring this y squared over. Y squared x minus this y squared. I'm going to subtract this x because this x is not a troublemaker to the other side. I'm going to factor out y squared. And I'm going to divide away the x minus 1. Divide away the x minus 1. Y squared equals negative x on x minus 1. And now y equals plus or minus square root of negative x on x minus 1. And that's where it's kind of an indication, hey, this function doesn't have an inverse function. But what about when x is greater than or equal to 0? Let's take a look at this graph. Y equals clear, because maybe that x is greater than or equal to 0 clears up any trouble that we might have. So here we go. Carefully now. I want x squared on x squared plus 1. I'm going to go back to Zoom Standard. I might have been in it already. We got a pretty interesting looking graph there. I'm going to change my window from -1 to 2 for my y's. Windows. -1 to, I'm even going to go 1.5 based on what I saw. Let's take a look here. And that graph is definitely not 1-to-1. However, I would suggest it might be 1-to-1 if we only looked to the right of 0. It appears like it's 1-to-1 to the right of 0. And now here's where we have to analyze the graph. The graph of this thing to the right of 0 looks something like, it looks kind of flat here, it comes up. Looks like it continues up forever. What would the reflection of that thing look like? Well, let's go ahead and graph this and see. Let's go ahead and go y equals, let's go with 2. I'm going to go with the positive version first and take a look. Square root fraction negative x on x minus 1. Let's graph that one. So we've got this guy right here, and if I put that back in Zoom Standard, maybe we'll be able to see what's going on with that reflection across y equals x. And it just gets so steep here, I think it just dies out. But it definitely looks like that's a reflection across right there, and it's not a reflection of the left part of this. So which part do we want here? We want y to equal this, and I want my x values to be to the right of 0 here as well. So x is greater than or equal to 0. And that really is kind of an outlier type problem here. More discussion on that. And this is more of a, if I had a question like that on a test or quiz, there would be some extra credit possibilities for you. If you got to this point right here, and even if you got to that point on a quiz without calculator and said, I don't believe it's 1-to-1. Well, the graph of this is not 1-to-1, but it is 1-to-1 to the right of there. There would be some extra credit opportunities on a problem like that. As with 78, but let's take a look at it. Find an inverse function of f algebraically. Use the graphing calculator. To graph both f and f inverse in the same viewing window, describe the relationship between the graphs. So square root of 16 minus x squared. Let's go ahead and graph it first. Take a look. Clear that one, clear that mess. Let's go second square root 16 minus x squared. And I'm really only interested in -4 to 0. So we graph this thing. Let's take a look. Zoom 6. The graph of this actually, you'd say it looks kind of like half an ellipse, but it's actually half a circle because that's up 4, that's right 4, that's left 4. So the graph of this thing looks like this. We've had this discussion a lot of times. No doubt it makes it to the point 4, 0. We can see that right there. So we would say initially, hey, that graph does not have an inverse. It's not 1-to-1. But we are only looking at the graph, this portion of the graph right here. We're not looking at that part. And if we were to reflect that through y equals x, I think pretty clearly 0, 4 would become 4, 0. Negative 4, 0 becomes 0, negative 4. We're looking for that part right there, aren't we? There's, if this is f of x right here, here's f inverse of x right there. All right, let's go through the process, the algebraic process. X equals square root 16 minus y squared. X's become y's. Solve for y. I'm going to square both sides. X squared equals 16 minus y squared. I think I'll add y squared. Y squared equals 16. I'm going to subtract x squared at minus x squared. Y equals plus or minus square root of 16 minus x squared. How about that? We ended up with the exact same thing because it's on the exact same circle. Now, do we want the positive y's or do we want the negative y's? That's the choice for our inverse. Well, our y's down here are negative. So f inverse of x is negative square root of 16 minus x squared. More little trickery there. Okay, that takes care of page 4. Again, this, I'm not saying this homework problem is extra credit, but if it was on a quiz or test, there would be some extra credit tied in with that and some extra credit tied in with number 70. But I wanted to introduce those to you. Okay, and we will be jumping on to page 5. So come back and join us there.